Welcome to today's session. In today's session, we will discuss about the topic analog pulse modulation schemes. Already we discussed about our analog modulation schemes like AM, FM, PM, amplitude modulation, frequency modulation, and phase modulation. Coming to today's topic like analog pulse modulation techniques known as PAM, PWM, and PPM, pulse amplitude modulation, pulse width modulation, and pulse position modulation. First of all, we will understand what is the difference between analog modulation techniques and analog pulse modulation techniques. In AM and FM PM, we will be using the message signal as sine wave or cosine wave, that is continuous wave signal, and the carrier signal also will be represented by the continuous wave signal, that is waveform, that is either sine wave or cosine wave. But coming to here in analog pulse modulation schemes, the carrier signal will be taken as pulse. Input is message signal, just like continuous signal like waveforms. Here it is carrier signal will be taken as pulse that we will observe while seeing the waveforms. So coming to the types, first it is divided into two types like pulse amplitude modulation and pulse time modulation. The pulse time modulation is further divided into two types, that is pulse width modulation and pulse position modulation. Now we will see about PAM. Coming to the definition of pulse amplitude modulation, the amplitude of the carrier pulse train is varied in accordance with the modulating signal. Here again we have two types depending upon the output, whether it is flat top or natural type or ideal type. Actually here flat top PAM is widely used because of easy noise removal. Coming to the waveforms, here the PAM looks like this, where the amplitude of the carrier, so here you can observe the carrier is in the form of pulse. Amplitude of this carrier will be varied with respect to instantaneous variation of input message signal, that is PAM. Coming to the generation of PAM signal, we will be using a simple sample and hold circuit. This sample and hold circuit is shown in the figure. It consists of two FETs and a capacitor C. These FETs will act as a switches. First one will act as a sampling switch where it will close for a short duration for a short pulse applied at the input, that is gate G1 of transistor. During this pulse period, the capacitor, as it is closed switch, it will act as the capacitor will goes to the charging position to the voltage, which is equal to the instantaneous value of amplitude of input message signal. Means see here, for this particular period, it will starts to charge. Then again the sampling switch is opened and opened due to the input negative half cycle, then the capacitor holds the charge. Now the discharge switch is then closed by a pulse applied to the, this is discharge switch. This discharge switch will be closed by a pulse applied to the gate G2 of second transistor. Due to this, the capacitor will be discharged to 0. So the charging, due to the charging and discharging of the capacitor, how the charging and discharging will happen means charging will happen by the capacitor G1 of the first phase. The capacitor will charges a pulse applied to the G1 of first FET, and the capacitor starts to discharge by the pulse applied to the gate G2 of the second FET. Hence, the output of sample and whole circuit consists of a sequence of flat top pulses. So, message signal, and here carrier is pulse, and then this is the pulse applied at gate G1 and this is the pulse applied at gate G2. So due to this the capacitor starts to charge, and until the second pulse applied to the second FET, it will holds that particular thing. Then immediately after the second pulse applied, it will starts to discharge and then charge, discharge, charge, discharge, so that we will be getting this particular output, which will looks like a PAM output. Coming to the transmission bandwidth of PAM, PAM signal is the pulse duration tau, where tau should be less than or equals to TS. And generation we have seen demodulation. Demodulation of PAM is the reverse process of modulation. We all know that demodulation means. Here we will be using a simple low pass filter. As the block diagram you can see here, a holding circuit and low pass filter. A holding circuit consists of a switch and as well as capacitor C. So that here we can recover our original message signal by this particular peak amplitudes. If you observe, due to this capacitor charging and discharging, we can, if you join the peak amplitudes, we can get the output of it will looks like input message signal, so that we can obtain our output, that is nothing but modulating signal. So coming to advantages and disadvantages of PAM. Advantages: simple process for modulation and demodulation. Disadvantages: bandwidth requirement is high, interference of noise is maximum, power requirement is high. And we can apply these PAM in microcontrollers for generating control signals, and these are used as electronic driver for LED lighting also. Thank you for listening me. In the next session we will discuss about our PWM and PP.